So we have seen the picture before. Um, we mentioned in 23-11 release on Classic platform, we had 4 in-vehicle communication related concepts or extensions introduced. Please note that TSN and DDS support on CP were initially actually already introduced in 22-11 release. And for 23-11 release, this release brings noteworthy updates on TSN concept. I will later delve into TSN concept a little bit, and Ahmed will present a comprehensive breakdown of 2 new concepts, charging interface and service discovery control for application software. Then, getting started with time-sensitive network concept. We all know that Ethernet communication is non-deterministic communication, but for some scenarios like audio-video streaming, like sensor fusion, or some other time-critical applications, you do need deterministic communication for such latency-critical communication, even also for big data transfer. With applying and configuring TSN features properly, the Ethernet communication can be deterministic. And for deterministic communication, the essence and the basis is precise time distribution and synchronization. In this context, time-sensitive network concept in 23-11 enhances precision for global time synchronization. AutoZa introduces in this release different measures to achieve high precision of global time sync. Look into the architecture view. The software modules in green frame here are the modules affected or extended for improving the precision. AutoZa introduces neighbor rate ratio calculation in Ethernet timesync modules following IEEE generalized PTP 2020 version, which is the latest version. Neighbor rate ratio calculation is used to compensate for frequency drifts between different clocks. This calculation is necessary for high accuracy when error timestamps are taken from different clocks. Now, the Ethernet controller supports up to 2 hardware clocks to perform hardware timestamping. For timesync frames, Ethernet driver can select hardware clock source for timestamping, free-running hardware clock, or PTP hardware clock. This enables also multi-time domain time synchronization scenario. PTP hardware clock is newly introduced in AutoZa. The synchronized time-based manager supports rate and offset correction for a PTP hardware clock unit for more accurate time synchronization. One new feature to facilitate validation of synchronized time is introduced also in Ethernet driver, supporting configuration of paths per second signal generation. For example, talker and listener can output to the PBS dedicated pin a very precise raising aged path every second. This can be used for measurement with oscilloscope, which is quite simple validation setup. So, moving on. Besides this enhancement, AutoZa also introduces new modules. For example, these solid green blocks here. For example, IEEE 1722 TP module to support stream handling between talkers and listeners, or in other words, between producers and consumers here to communicate. The behavior of this new module refers to IEEE 1722 protocol or audio-video transport protocol, which is level 2 transport protocol. This module supports also transmission and reception of AVTP streams, understands audio AVTP audio format, understands also IEC 61883 and IIDC protocols for audio and video, as well as raw video format. Control streams can also be supported, like the clock reference format, allowing dissemination of a common clock to multiple talkers and listeners. ACM messages with time-sensitive or non-time-sensitive control format header are supported. ACF messages can encapsulate, for example, the legacy communication messages like CAN, FlexRay, LIN messages in Ethernet frames. This is also an enabler for low-level frame tunneling use case. In order to have high quality of service, Ethernet switch driver got extended as a precondition for filtering, policing, or shaping algorithm. Stream identification is required. Ethernet switch now supports passive stream identification, which performs things like deep packet inspection without changing the content of the packet itself to identify streams by stream ID. Switch now supports per-stream filtering and policing capabilities that allow filtering and policing decisions and subsequent frame queuing decisions to be made on a per-stream basis as name told for received frames instead of per class. In order to achieve bounded low latency and zero congestion loss, namely to reduce bursts of high priority traffic, for example, to reduce worst case latencies for low priority traffic, the credit-based shaper algorithm got updated in this release, and also asynchronous traffic shaper is newly introduced, which requires no clock reference, which means bypassing complex setup and maintenance of time synchronization for easy setup. The last key feature in this release is the introduction of optional hardware-supported data transfer via DMA for efficient handling of large data transfer.